Hello, this is Mr. Hill, and this is the first video in our new Flipped Classroom series. Each night you'll be able to find a video here on our YouTube channel. You'll be able to take notes and bring those notes with you to class the next day, where we'll then get into small groups and complete what we would traditionally call our homework assignment that we used to do outside of school, and we're going to flip it all around and now do that part in the classroom. I'll be able to answer your questions one-on-one and be able to give a little more specific assistance to each student. So here goes nothing. There's bound to be some hiccups as we go, and please be patient as I learn these new tools. Thank you. Our title today is called Quadratic Inequalities, specifically with one variable. And the first example I want to take a look at is x squared plus x minus 2 is greater than 0. And the first question I want to ask you is simply, is x equals 10 a solution to this quadratic inequality? All we're going to do is substitute the 10 in for each x value. So we have 10 squared plus 10 minus 2. Is that really greater than 0? And as we do our number crunching, and feel free to either do that in your head or on your calculator, I ended up getting 108. And so we ask ourselves, is 108 truly greater than 0? I would say true. Therefore, x equals 10 is indeed a solution to this quadratic inequality. For our second example, we're going to stick with the same quadratic inequality, x squared plus x minus 2 is greater than 0. However, I'm just going to tweak it just a little bit and ask you, is x equals negative 1 a solution to this quadratic inequality? And we're going to follow a similar process where we substitute the negative 1 in for x. Notice the parentheses that we're using to help us handle that negative sign. And as we evaluate these numbers, I ended up getting negative 2. And then we ask ourselves, is negative 2 really greater than 0? And I would certainly say false to that statement. Therefore, x equals negative 1 is not a solution to this quadratic inequality. Now we could continue with this process and continue to substitute various numbers in for x as we venture on this quest to find solutions. However, we're going to talk about a much shorter process that's going to lead us to our direct answers. And we want to stress that there are many, many solutions to this quadratic inequality. However, finding which ones are good values of x and which ones don't work is going to be the goal of this topic. For our first example, we're going to try to solve the quadratic inequality x squared plus x minus 2 is greater than 0. Our first step says to rewrite as a quadratic equation, x squared plus x minus 2 is now equals to 0, and to find the roots. The good news is, as we'll find with most of our examples today, is that it is a factorable equation. And we're trying to think of two numbers that add up to positive 1 for the b term here in the middle, and also multiply to negative 2. I'm going to choose x plus 2 times the quantity x minus 1. Then we're simply going to tee this up and say that x equals negative 2 is one of the roots, and x equals positive 1 is the second root. Our second and most challenging step is to construct a sign chart. Now my sign chart is simply a number line that extends from, on the left side, negative infinity, all the way to positive infinity on the right side. We're going to make special notes of our roots, negative 2 and positive 1. And then what we're going to do is we're going to pick numbers that fall within each of the three intervals. For instance, our first interval starts at negative infinity and ends at negative 2. A friendly number that falls within that interval is perhaps negative 3. And I'm going to use that as my test value. The key here is we're going to substitute that negative 3 into the original quadratic inequality. Now if you recall, x squared plus x minus 2 was the original equation. So I'm going to substitute the negative 3 in for those x's. Whoops, almost forgot the negative there. Minus 2. So we've got 9 minus 3 is 6. 6 minus 2 gave me 4. And the key is not so much the 4 as it is I want to focus on the fact that we got a positive answer when we inserted or substituted the negative 3 in for x. Moving on to our second interval that starts with negative 2 and ends with positive 1. the friendliest number that falls within that interval is a 0. That's my new test point, and I'm going to substitute the 0 into the original equation. My dog Bailey is very close to the iPad right now, and if you hear any noise, it's his fault. Anyway, when we evaluate the 0, we get negative 2. Again, the focus is not on the 2 as much as the fact that we got a negative answer. And we'll fill in our sign chart with a series of negatives. Last but not least is our third interval that starts at 1 and ends at infinity. A nice number within that interval is a 2. Substituting the 2 into the original equation, we ended up getting 4 plus 2 is 6, 6 minus 2 is a 4, and again we got a positive answer. Now that we've completed our sign chart, our third and final step is to identify our answer two different ways. First, let's identify our answer graphically. Because we're only working with one variable today, graphically means our solution is going to be on a single number line. I'm going to use open circles because in the original problem, they asked me when is the quadratic greater than 0. Open circles because we said just greater than. If we had said greater than or equal to, then it would have been a closed circle on that one. But because they just said greater, we're going with an open circle. Now, greater than 0 is a mathematical way of saying we want positive answers. If you refer back to your sign chart, where were your positive values? In the first interval and then the third interval. So I'm going to shade to the left of negative 2, and I'm also going to shade to the right of positive 1, indicating that that's where my positive values were. Now for my interval notation. This is that really fancy, ugly notation that we used earlier in the year where we say all x values such that x is less than negative 2 or x is greater than 1 satisfy the given quadratic inequality. Well, there you have it, folks. There's our first example for quadratic inequalities. Let's try another one and see if it looks a little better. The second quadratic inequality we want to attempt to solve asks us to solve x squared minus 4x minus 12 is less than or equal to 0. Now you'll notice we didn't just say less than 0, we said less than or equal to 0, which in the back of my mind I'm going to make a mental note that I'm going to use closed circles on my number line later on in the problem. That's just one little tip that we often forget when we get to the end of the problem. If you recall from our last example, step 1 said we want to rewrite the equation, rewrite the quadratic in terms of an equation, and then try to find the roots. Again, all of our examples today will be very friendly quadratics that factor quite nicely. And as we tee this up, we could say that our roots are x equals positive 6 and x equals negative 2. Step number 2 is to construct a nice sign chart that extends from negative infinity to positive infinity. We'll recognize our two roots as negative 2 and positive 6. And now we're going to try to pick some friendly numbers that fall within those intervals. Last time I used negative 10 for the first interval. This time, just to prove to you that it doesn't always have to be negative 10, I'm going to choose negative 4. And as I plug that into the original, I'm going to say negative 4 squared minus 4 times negative 4, minus 12. And as I work that out, I ended up getting a positive 20. Be very careful when typing that into your calculator. Make sure you use the appropriate parentheses just as we've used here as we've written it out. The bottom line is that we got a positive answer. That's what we're really focused on. My second interval starts with negative 2 and ends with positive 6. The friendliest number within that interval is 0. Certainly you could have chosen a positive 1 or a positive 2 or any number that falls between negative 2 and 6. As we plug that into the original, we have 0 squared minus 4 times 0 minus 12. As we work that out, we get negative 12, our focus being on the fact that we got a negative answer. Last but not least, our third interval starts with 6 and ends with positive infinity. I'm going to pick a 10. A 10 is always a nice number to work with. 10 squared minus 4 times 10 minus 12 gives me 48. Focus being on the fact that we got a positive answer. At this point, we've finished our sign chart, and we're going to move on to our third and final step. Our third step says we need to identify our answer in two ways. First of all, graphically. We're just going to reconstruct a number line, roots being at -2 and +6. And you'll recall that our original quadratic inequality said less than or equal to 0. So that means mathematically we're looking for negative numbers. The only interval that was negative was the one in the middle here. So I'm going to put a closed circle on -2, a closed circle on +6, and we're going to shade in between those two closed dots. Any number in between -2 and +6 produced a negative value. The second way we're going to identify our answer is using interval notation, and we're going to say all values of x such that -2 is less than or equal to x, which is less than or equal to 6. And that's just our way of saying that any number that falls between -2 and +6 is a member of our solution set. Well, ladies and gentlemen, we finished two examples. Let's try one more just to be safe. Our third and final example looks like this. And you'll notice we did try to sneak in a mini bear trap here. Whoops, time out. I already goofed this one up. I want to try to put an X on this side. So did you recognize our bear trap? This quadratic's not in standard form yet. We always want to make sure that there's a 0 over here on this one side. So simply, all we're going to do is subtract that x over, and we're going to put it right in the middle. That's our b term. Once we subtract that x over and get it so there's a 0 on the right side, now it's in what we call standard form, and we're ready to go ahead. I'd encourage you to try to hit the pause button here and to try to solve this one on your own, and then go back, hit play, and see if you got the same solutions that I did. Step 1 says I'm going to rewrite the quadratic as an equation and go ahead and find the roots as we normally would. Again, it factored very nicely. X minus 4 times the quantity x plus 3. Why did we get -4 and 3? Well, certainly, if you add these two numbers together, you'll get a coefficient of -1, and if we multiply them together, we'll get a coefficient of -12 for the c term. As we tee it up, we have roots of +4 and -3. Step number 2 wants us to construct a sign chart that extends from -infinity on the left side all the way to +infinity on the right side. We'll identify our roots as being -3 and +4, and we're going to pick some nice test points that fall within these intervals. I'm going to choose -4 as a test point. And as I plug that into the original quadratic, I ended up getting a +8, which is certainly a positive number. In our second interval that starts with -3 and ends with 4, my favorite number of all time, 0. We plug that into the original quadratic, and I got -12. Certainly a negative number. Last but not least, our third interval starts with 4 and ends with +infinity. I'm going to pick a 5. And as I plug that into the original quadratic, I ended up with an answer of 8, which is positive. We've now finished our sign chart. Our third and final step is to identify our solutions. Now, just to refresh your memory, our original problem said x squared minus x minus 12 wanted to be greater than 0. Greater than 0 implies that we're looking for positive numbers, aka the plus signs that we used up here. On our number line, once we identify our roots, I'm going to use open circles because our inequality was greater than, it did not say greater than or equal to. And then I'm going to shade to the left of -3 and also to the right of +4. If we want to represent our answer using interval notation, we could say all values of x such that x is less than -3 or x is greater than +4. Well, there we go. We've just finished our first flipped lesson. Hopefully we took some good notes, and when we see you in class tomorrow, we'll be ready to try some more examples together. Good luck.